Hello and welcome to a Maths with Harry lesson. In this video, we're going to be having a look at simultaneous equations. For this lesson, we're going to have a look at linear simultaneous equations. And in the next lesson, we're going to have a look at quadratic simultaneous equations. So I'll write that down here. We're going to have a look at linear. And we're going to have a look at two methods we can use to solve linear simultaneous equations. You probably have seen these before at GCSE. But they come up a little bit at A-level and you need to be able to solve them. So we're going to have a look at two methods today. The first method we're going to have a look at is called elimination. And the second method is called substitution. So what I'm going to do is I'm going to introduce the method to you first and then we'll have a look at some examples. But you probably have seen these two methods before. So this first method is going to be elimination. And it's kind of in the title. What we want to do with elimination is eliminate one of the variables. So the first thing we're going to do is we are going to eliminate x or y. Now, you actually might not have variables x and y, you might have a or b or p and q. For this video, we've just got variables x and y, but what you want to do is eliminate one of those two variables, and I'll show you how you do that in some examples. Then, when we've eliminated one of them, we're just going to have one variable left, so what we want to do is solve for the other variable. And the other variable is the variable that you didn't eliminate in part one. Okay? Then once you've done that, what you want to do is, well, you're going to find in part two the value of either x or y. You want to substitute that value back in to either original equation to find the value of the other. So we're going to sub our known value, and when I write sub, I mean substitute, sub our known value, or variable in this case we could say, our known variable into an equation to find the other variable, okay, or the value of the other variable. So eliminate x or y, or if it's p and q or a and b or whatever variables you've got, eliminate one of them, find the value of the other one that you didn't eliminate, then substitute that one back into one of the other original equations to find the value of the other variable. Okay, so let's have a look at an example. You can pause this video if you want to and have a go at it, because you might be able to do this at GCSE, but if not, don't pause it and we'll work through it straight away. Okay, hopefully if you paused, you've had a go, and let's see if your answer is correct. So what we want to do here is we want to solve the linear simultaneous equations. We've got two equations here. We know they're linear because there's no powers of 2 or 3 or 4. There's just x and y. We have linear variables here. So they're both linear, and they're simultaneous because we want to solve them together. Simultaneous means they happen together, they happen at the same time. So really being asked is what are the two values that kind of satisfy both of these equations. Okay? So, the first thing we need to do, like I said, is eliminate x or y. So to do that, what we can either do is we can add the two equations together, or we can subtract the two equations. And what I mean by adding or subtracting them together is sort of adding the x parts together, adding the y parts and adding our constant terms on the right hand side, or if we're taking them away, then we take each part of the equation away from each other. Now, what we want to do is eliminate one of the variables, and I here am going to eliminate x. If you, when you paused, eliminated y, don't worry, that's absolutely fine, but you can see that we've got the same number of x's in both equations here. If I call this equation 1 and I call that equation 2, it might help me in my working to sort of label them and use that labeling when I'm working the values out. So, what I'm going to do is I'm going to subtract these two equations. I'm going to do 2 minus 1. And the reason I'm going to do that is because when I subtract them, like I said, we have the same number of x's in each equation. So if I write in red here little subtraction signs at each part of the equation, we can see that what's going to happen, and I'll get a red highlighter there, those x parts on both of the equations are going to cancel out because 2x minus 2x gives me 0. So when I subtract them, I end up with no x's. And that's good because we wanted to eliminate either x or y. So let's subtract the other parts of the equation. I've done 2 minus 1, so I'm going to have 6y minus 2y on the left-hand side. And then on the right-hand side, I'm going to have 55 minus 33. And when I do that, I get 22. Okay? And then what I need to do is, well, I can just solve for y here. We've got 6y minus 2y. That gives me 4y. And then we get that is equal to 22. And then what I can do is I can divide both sides by 4 to get y is equal to 22 over 4. And then we can divide top and bottom by 2 there to give me 11 over 2. So that is, and I'll write that actually underneath, y equals 11 over 2. That is our value for y. So all we did was eliminated and then solve for the other variables. So that's part 1 and 2 complete. Here was where we eliminated because we subtracted the two equations away from each other to eliminate x. We were left with just y, and then part 2 said, well, let's solve it, okay? Now what we need to do is we need to substitute this known value into an equation, because then what will happen is we'll end up with our eliminated variable just on its own because we're substituting y, and then we can solve for x in this case. Okay, so now I'm going to substitute, and again, sub is short for substitute. Substitute that into either equation 1 or equation 2. I don't really mind which one we substitute it in here. I'm going to have a look at my solutions to see which one I did. You can actually do both and you'll get the same answer. I'm going to substitute it into equation 1, okay? Sometimes you might find it's easier to substitute it maybe into equation 1 or equation 2. And what makes it easier? Well, it's easier if it doesn't have negatives, so you don't get confused with negatives, or if the numbers are just nicer in a certain equation, make it easy for yourself and substitute it into the easier equation. Okay, so that's what we've got here. I'm going to substitute it into 1. So 1 is 2x plus 2y equals 33. So 2x plus 2y is equal to 33. So y was equal to 11 over 2, so we'll end up with 2x plus 2 times 11 over 2 is equal to 33. And then we can see here that this 2 and that 2 are going to cancel. So that will give me, I'll write it down here, 2x plus 11 is equal to 33. And then what I can do is I can take 11 from both sides. It's now just solving a normal linear equation. So I'm going to have 2x will be equal to 22, and then I can write, well, that's going to tell me that x will be equal to 11. And that then is my value for x. And then what we can do is we can say, and so, and I always like to write this at the end, x is equal to 11, and y is equal to 11 over 2. And that's just a nice way to finish off your answer. Now, to check whether you've got the right answer, you must substitute them back into both equations. So what you can do is you can put x into here as 11 and y as 11 over 2 into there and see whether you get 33. And here you can do 2 times 11 again and 6 times 11 over 2, and you should get 55. Okay, so that's really a good thing to do when you finish your solution. And that way in an exam, if you get a question like this, or if it's involved in a bigger question, you can know that you've got yourself some marks. Okay, so not very difficult. You've probably seen it before. Now let's have a go at the next example, which is here. Example 2, we want to solve. Again, they are linear simultaneous equations. We've got different numbers here. We've got 2x plus 3y is equal to 8. And we've got 3x minus y is equal to 23. So again, Press pause if you want to, have a go, and then we'll work through the answer. Okay, hopefully you had a go. Now here, it's not really obvious which variable we can eliminate, because we can actually eliminate both, but there's a little extra step that you need to do here. I'm going to eliminate y in this case, and I'm going to work out what x is first, okay? So to eliminate y, what I need to do is add or subtract the two equations together. But I can see I don't have the same number of y's in both equations. If we look at the first example, we have 2x in both equations, so it was easy for us just to subtract and then get 0, or 0 x's. Here, we're not too sure. Now, what we need to do first is we need to multiply this equation, and again, if I call them equation 1 and equation 2, we need to multiply this equation by 3. And then that way, we'll have not the same number because we've got -3 and a +3 here, but if we think, like, let's ignore the signs, we've got the same value of y in both equations. Okay, so what I'm going to do is I'm going to first do equation 2 times 3. And when I do that, I'm going to have 9x minus 3y is equal to, and we multiply that by 3, that's going to be 69. Okay, then what we can do is we can now add the two equations together. If I call this now equation 3, I'm going to add this equation and this equation together. When I add them, we're going to eliminate y. Because if I write them out together, 2x plus 3y is equal to 8, and 9x minus 3y is equal to 69, what we can have here is, well, if we, and I'll add everything together, if we do that, we will get 3y plus minus 3y. And then, nicely, they will just cancel each other out to give me 0. So when we've got different signs, like we have here, we need to add the two equations together. But in this case, we needed to multiply this equation by 3. So that's going to eliminate our y, and we'll be left with 2x, oh, just go back to black here, 2x plus 9x will be equal to 8 plus 69, and we're just adding those two parts together. We added these two to get 0, so the y's have disappeared. And then what we get is we get 11x is equal to 77, and then we can divide both sides by 11. So we'll get x is equal to 7. And that is our value for x. So again, what we've done there is part 1 and 2 of our elimination method. All we did was we eliminated a variable, but we had to multiply first, eliminated, and then we've solved for our variable that we didn't eliminate. Okay, so we've solved for x here. Now what we need to do is we need to solve for our variable that we eliminated, because we've got our value for x, we need a value for y as well. So I'm going to substitute that into either equation 1 or equation 2. I'm going to substitute it into, and in this case, I'm going to do equation 2. There is a minus here, but I'm not too bothered about that because the numbers are a little bit smaller than in here, apart from this 23. So I'm going to substitute it into part 2. Okay, so sub x is equal to 7 into 2. And that will give us this. We will have 3 times 7 minus y is equal to 23. That's 21 minus y is equal to 23. And then we could maybe see that straight off, that we know what y is, or we might not, doesn't really matter. But let me see what we get here. So we've just substituted that in just correctly. Let me check. Yes, I have. So we're going to have 21 minus 23 is equal to y. And with it, we will then get y is equal to minus 2. Okay. And I'm just checking I have done that correctly because I've got a different value here. Yes, that is correct. Perfect. Okay, so y is equal to minus 2. And again, we can check whether we've done that correctly. If we substitute into, let's do number 1. If we substitute into number 1, we'll have 2x plus 3y is equal to 8. And we've got here 2 times 7 plus 3 times minus 2. Does that equal 8? Well, that's 14 minus 6, and that does give us 8. So perfect, those are our correct values. And again, you could write this at the bottom just to summarise your answer. Okay, so that's all we needed to do. We've found our value for x and we've found our value for y, so that is perfect. Okay, let's have a look at another example, and again, let's pause the video if you want to and work through it. If not, we'll work through it in a minute. Okay, let's have a look. Hopefully you had a go. Again, we want to solve the linear simultaneous equations, and actually this time we do have a and b. I thought they were all x and y, they're not. We've got a and b here. So what we want to do in this case is eliminate either a or eliminate either b. Okay, now there's a little step that we need to do to both equations here before we do anything. We need the same value of a or b in each equation. I'm going to eliminate a here, and I'm going to do that by getting the same value for a in, or the same number of a's in each equation. To do that, I'm going to again call this number 1 and this number 2. What I'm going to do is I'm going to multiply equation 1 by something and equation 2 by something else. Because we have got 4a in equation 2, I'm going to multiply equation 1 by 4. So equation 1 by 4, okay? And when I do that, I'm going to get this. I'm going to get 12a plus 16b, and that's going to give me 24 times 4, which is 96, okay? I'm going to call that then equation 3. And then I also need the same number of a's in equation 2 as well. What I'm going to do with equation 2 is I'm going to multiply that one by 3, because we've got 3a in the first equation. So when I do that, I get this. I get 12a plus 9b is equal to 66, and we'll call that equation 4. So now what we can do is we can just eliminate a by subtracting the two equations. So in red here, if I subtract all of these parts, we can see that that part there is going to disappear, because we've got 12a minus 12a. So then here what we're going to have is 16b minus 9b, and that's going to leave me with, and I'll go back to black, that's going to be 16b minus 9b, and we'll substitute that in a minute actually. 96 minus 66 will give me 30, and then all we need to do is simplify. So we can do that here. That's now going to give me 7b is equal to 30, and so b is equal to 30 over 7. We can just divide both sides by 7. Now that is my value for b. So just look here, we eliminated a by multiplying 1 by 4 and multiplying 2 by 3, and then we eliminated a to find out b. Now all we need to do is part 3, substitute our known variable back into either 1 or 2 to find out the value of our eliminated variable. I'm going to substitute this into number 2, so let's write it down here. Sub b equal to 30 over 7 into equation 2. Now equation 2, we'll just write it here, was 4a plus 3b is equal to 22, and we're just going to substitute that in. So 4a plus 3 times 30 over 7 is equal to 22. We could do a little bit of simplification here. We're going to get 4a plus 90 over 7 is equal to 22. And then we're going to have 4a, we could take off 90 over 7 from both sides to give us 64 over 7. And then we can divide both sides by 4 to give me a is 16 over 7. So there is our value for a. We found our value for a, and firstly we found our value for b. A and b were the only variables in these two equations, so we're fine, we've finished our solution. Okay, so those are 3 examples of how we can use the method elimination to find our values in our simultaneous equations. Now, there is a different method, and you've probably also seen this one before as well, but let me run through what you need to do. So it's quite similar, but what we do is we rearrange either equation 1 or equation 2 to give us, if our two variables are x and y, either x equals something or y equals something. You decide which one you want to rearrange for. So let's say rearrange either equation into the form and either x equals or y equals. Then what we do is we substitute part 1 into the equation that we didn't rearrange. So sub part 1 into equation that we didn't rearrange. So if we rearranged number 1, we'll substitute the rearranged version of number 1 into number 2. And then all we're going to do is we are going to solve for that variable. Okay, so solve now for the variable that's going to be left in part 2. And I also do need another part here as well. Part 4, we are then, once we've got that variable that was left over, we're going to substitute back into the rearranged equation. To find the eliminated variable, the variable that we don't know yet. Okay, so might seem a little bit complicated if you haven't seen this before, but we'll work through an example now. So I've summarised the method there into part 1, 2, 3 and in part 4 as well. So have a go at the example. Use the method if you want to, press pause and have a go, and then I'll work through the answer. Okay, hopefully you had a go. Let's see whether your answer is correct. So it's actually the same two equations as example 1. So hopefully you're able to check if you got example 1 right. So what we need to do first is we need to rearrange either equation 1 or 2 to give x equals something or y equals something. I'm going to choose x equals something. So let's call this, equation 1 and that equation 2. I'm going to rearrange equation 1, so we'll call this part 1, and I'm going to get x equals. So first thing I'm going to do is minus 2y from both sides to give me that. And then what I'm going to do is, well, I've got 2x equals something, I just need x. So what I'm going to do is divide both sides by 2. So I get 33 minus 2y, all divided by 2. I'm going to highlight that in grey because I'm going to use that in a minute. So part 2 then says substitute part 1 into the other equation. So I'm going to substitute this into equation 2 here. Okay, so I'll call this now part 2. We're going to get 2x plus 6y is equal to 55, but I know what x is in terms of y, so I can substitute x in here. So we're going to have 2 times 33 minus 2y divided by 2 plus 6y is equal to 55. The 2's will then cancel to give me 33 minus 2y, and then plus 6y is equal to 55, and then we're going to have 4y with the 33 as well, plus 4y is equal to 55, and then I can take off 33 from both sides to give me 22, and then y will be equal to 11 over 2, just like our previous example. Okay? Then what we're going to do is we're going to solve for the other variable. Now to do that, I'm going to substitute this value of y, and I think I wrote it differently up here. Yes, solve for the variable in part 2. So we're going to solve for x now, because we know the value of y. So we just need to substitute y into this equation here. And we don't actually need part 4 there, do we? No, we don't. Okay, so part 3 says x will be equal to 33 minus 2 times 11 over 2 divided by, and then we're going to have 2 on the bottom, that will give me 33 minus 11 over 2, which will be 22 over 2, which is 11. And so that tells me x is equal to 11. And that's exactly what we had originally. So we can see that the two methods are quite similar, but this one involved a little bit of rearranging. We didn't cancel out our two x's straight away. We rearranged. We substituted part 1 into here, we got our variable, and then we don't actually need part 4 on there because we've kind of already done that. We just then need to solve for this other variable here by substituting our y value in to give us x.